Welcome to this episode of arcade-cabinets.com. In this episode, we are going to repair an Atari Xevious PCB, but we're going to do a little different approach. Rather than go about the problem very targeted, which I usually have an idea what's wrong with the board, I'm taking this from the beginning and covering step by step the process, because the Xevious CPU has 3 processors and it's a lot more complex than most games that we've worked on. So I'm going to take you through the process and some of the theory of how you would troubleshoot this. And this is episode 1 of 2 episodes. There'll be a second episode finishing up where we left off. So let's begin.
So here we have a Xevious PCB. It doesn't work. And it's not even has all its chips. But that's okay, because we're going to test this one component at a time, which you can do that. We can test this CPU and its access to RAM and its own ROMs, then this one, then this one. And then if everything works out correctly, by the time we put it all back together, it should work, theoretically. It might have graphics issues or sound issues. It doesn't have graphics issues because I've tested the graphics board. I know that one works. But let's take this piece by piece. So the first thing we're going to do is we're going to test that first processor. Turn it on, and I hit bus test, and look at that. Already we have something. Data bit 0 tied high. Well, what does that mean? That means that somewhere on this board, data bit 0 is pin 14. So more than likely, pin 14 is stuck to ground or +5. This chip, which controls the data bus, could be bad, but I know this one's okay. But these Xevious boards, usually most of them I've seen, their sockets are horrible. And if a socket is falling apart and it's not making contact, or it's got trace problems, maybe it broke off, I'm just going to go ahead and replace this, and this. Those 4 sockets, because these are the main components in this part of the CPU. So I replaced the sockets, put the Fluke back in, and while I was replacing that, I realized I had the wrong chip in there. I had this chip in there, and that's the wrong chip. So that could be why I was getting bus errors. But we got nice clean sockets in there. Of course, I lifted a couple traces, but those are fixed. So let's try this now. Okay, now we get a bus test okay. So let's go ahead and test out this chip right here. That's 1M. It should be, well, you'll see. So we'll do a ROM test. 0 to, this is a 64 K-bit chip, so it starts at 0, it goes through 1 FFF. And the signature we have, because I already printed it out on there, is 53BE. Okay, so that worked. That's a good sign. And I will tell you, I had actually tested it before I replaced those chips and replaced those sockets, and it actually was giving me the wrong. Let's go ahead and check the next range. ROM 2000 to 3FFF, and that was 0314. Okay, and that's good. Great. So this guy looks pretty good. Let's now check his ability to access the RAM at 8000 to 8FFF, which is actually on the video board. I know that RAM is good because that video board works fine with other working boards. So let's test that. I mean, there could be an error along the way between the main board and the video board that is giving us an issue. But I'm just going to do a short in this case rather than a long. And I'll do 8000 to 8FFF. I think that's going to work. Oh, I got a DCD error on bit 11. So, that makes sense. Because, you know what? Even though the range available is 8 through 8FFF, it only actually uses 8 to 83FF. The actual addresses after that, which is bit 11, are tied back to they're set specifically so that we'll actually get a DCD error. So let's just do that, and that should work fine. Okay, since we know that works, and I know that the other RAM ranges are on the video board, I'm not going to test them. I'm going to go ahead and move to the next CPU because I know the video board works and I know I can hit one of the RAM ranges on there. So there's nothing in between blocking me from hitting. There shouldn't be anything. There could be an address decoding issue, but I don't think there's going to be. So I'm going to go ahead and move on to the next CPU. So what I've done here is I've taken the buffer chip from there and put it here, and I removed the CPU and this buffer and remove that CPU. The reason I'm removing these CPUs is because I want to just isolate each individual processor in its local area at a time. This guy's the master. If he actually boots up and starts booting correctly, it could cause problems when I go to test this. So I'm just going to isolate everything. Okay. So I'm just testing this guy now. I've removed the CPU and the buffer. I could just remove theoretically just the buffer of each or the CPU of each, but I'm removing everything. So we're plugged in here. We have a code of E1FF. This is 32 kbit PROM, and its ROM range relative to its CPU is going to be 0 to FFF, because that's what 32 kbits of data is. And his code is E11F. So let's test him out and see how he goes. And he's okay. So let's just also test that quick RAM range on this video board, just to make sure he can get off as a local area. Because right now we're just going from that CPU directly to that EPROM. We're not leaving really that local area of that CPU. We're not going through that buffer chip and doing anything else. But now we're going to. So if I do a RAM short 8000 to 83FF, we'll see. Hopefully it'll come back okay. Now again, when doing a full test, you're going to want to test each RAM range from each CPU. But I just want to go through the steps for you, and because that will take all day. Well, not really, but you know what I'm saying. Okay, so that's fine. So let's move on to the next one. So here I'm going to remove this CPU and this buffer chip again. And I'm going to put the buffer chip in this guy here, isolating this guy. So he's the only one who's talking. And you can query all the rest of the system at once, or by himself. And that's a 64 kbit chip in there. So we'll go ahead and turn it on, do the bus test. Bus test is okay. And we're going to do the bus test on each CPU. And his range is from 0 to 1FFF. And his code is 4C5E. So that will take a few minutes, and hopefully he'll come back okay. And then we'll do a quick RAM test from the to hit the video board, and that's okay. And let's just do that quick RAM short of 8000 to 83FF. So he can read his ROM okay, and assuming this comes back okay, everything will be clear for him to accessing the ROM on the RAM on the video board. Okay, that's okay. So theoretically, everything should be working. These guys should be working. If I put everything back together, unless there's some other weird issue, some type of controller or synchronization issue, it's possible. And what you can actually do on Xevious is, if everything is working correctly, you should be able to put just this one CPU in and its buffer, and it should actually start booting and get through some of the tests. It would stop at, I think you'll get a RAM 7 error if you don't have the other guys in there, but you should actually be able to boot and see what happens. You should be able to see the boot set up. But it's still static, so somehow we're missing something. And I just thought of something, what it might be. I can't believe I didn't realize this before. But we'll cover that in the next episode, because I think we have enough material for this episode, and we don't want to bore everybody. So we'll cover that in the next episode. But I just want to show you, before I do go, that this guy should boot. If everything is working. I'm going to switch it out with a working board. I know this board works, because I just recently repaired it. I do want to show you that this guy will boot and start self-test mode. Well, it'll boot somewhat. It won't go all the way through. But it will start to get this, it will pass the test. If I put a working board in, and only the main CPU, you should actually see, when I power this on, it should start booting. There it goes. And it will eventually give you an error. There you go. RAM OK, ROM 7, sound. It doesn't go to the sound test, but it started booting. So you can see, actually, this Xevious board and Galaga boards, things like that, all you need to start the process is this main CPU and its code ROMs and the RAM on the CPU board.
So join us for the next episode when we take a look to see what I might have missed, what's still stopping this board from working. And of course, don't forget to hit that like button if you enjoyed this video, and tell your friends or people that you know who might be interested in this kind of material. And of course, please consider supporting us at our Patreon site, www.patreon.com/arcades. Thanks, see you next time.